All right, welcome back to Mr. P. House with Geometry's Unit 1, Topic 2, lesson number 4. So we're going to be reflecting a given figure over a given line of reflection. So starting with a warm-up here on translations, 3 units down, so all you have to do is move each point, slide each point, 1, 2, 3. So this is going to be U prime, this is going to be G prime, and 1, 2, 3, this will be L prime. So when it connects, you've got the exact same shape, same size, because it's a rigid transformation. 5 right, 2 up, 1, 2, 3, 4, 5, 1, 2 up. So I know this will be here, and this will be here. So every point ends up being the exact same location. Okay, so in this one, so we'll probably use a mirror, which is basically a reflecting device, which will make it look exactly the same. And if not, so it looks something like that, like a capital A. So what it is a mirror image on both sides, or like this one, so there would be the feet, and the arms will be like that, and then something like that. So if you put a mirror right here in the middle, and then you look through this side, you'll be able to draw the shape on the other side by looking through that mirror. So this is all about reflections. Now the point of reflections, as I skip to the most important part, is that a reflection is going to be equal distance to the line of symmetry. So when you look at A and A prime, A is 2 away to the line of symmetry, and A prime is 2 on the other side. So it's moving 2 to get to here, and then 2 more to get to on the other side. Now B is moving further. That's 1, 2, 3, 4, 5, 6. And then B prime would also be 6 away on the other side. So it's a mirror image on both sides. The further the point was away from the line of symmetry, then the further it's going to be when you reflect it. Now C didn't move. It's the fixed point. It's going to stay on the line of symmetry. Now D is moving left, in this case, 1, 2, 3, and then it moves 3 on the other side. All right, so that pretty much describes how I'm going to do these questions. Now, this happens to be the line x equals 2, because every point on this line of symmetry has an x of 2. 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. So what I'm going to do is I'm simply going to do a mirror image. So m is 1 away, and I'll do m prime on the other side, 1 away. H is 2 away, 1, 2. I just reflected onto the other side. So I literally count the blocks to get to the line of symmetry. So from A, 1, 2, 3, 4, 5. And then keep going, 1, 2, 3, 4, 5. And then once I've finished, then I can connect them up with my straight edge. And I've got literally the exact same shape, same size. It's just on the other side of the line of symmetry. Now, same goes for this question. Well, first of all, L is on the line of symmetry, so that will not move. A is only 1 away. I'm just reflecting it above, so I'm going to the other side of the line of symmetry. So if I have to go straight up 1, 2, 3, 1, 2, 3, there's M, and C is 1, 2, 1, 2. And then I can connect it up, and there's my reflection over. This happens to be Y equals 4. Now, anytime you have a vertical line, it's going to be x equals, and horizontals is y equals. Because if you think about it, every point on this line has a y of 4. 0, 4, 1, 4, 2, 4, 3, 4, 4, 4, and so forth. All right, so just a matter of counting to get to the line of symmetry. So this question, I'm taking an image on the left, and I'm flipping it over to the right. So 1 away, 1 away. 1, 2, 1, 2. 1, 2, 3, 4, 1, 2, 3, 4, and 1 away, 1 away. And then it's just a matter of connecting the points, like such. Okay, now what happened on here on number 4, the only thing that's different here is that 3 of the points are below the line. So when you reflect them, they'll end up above the line. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So points U, R, and T, 1, 2, 3, 4, 1, 2, 3, 4, end up above the line of symmetry. Whereas H was above the line of symmetry, so it will now reflect to the other side. So what ends up happening, since we have points on both sides of the line of symmetry, is that what happens is the reflection ends up being on top of itself by a little bit right here, because it was only that point H that was on the other side. Now, for this, we're doing the exact same thing. It says reflect JA over the line y equals -1, so that would be this line right here, reflect J, 1, 2, 1, 2. There's J prime there. And then A, 1, 2, 3, 4, 1, 2, 3, 4. The only difference is this is going to be a segment. So I'm going to connect my points up so that we have the exact same segment as was up there. Otherwise, everything's done exactly the same as I did on the last page. So this one is reflected over x equals -2, which is this point. Now, clearly, E is already on the line, 1, 2, 1, 2, and there you go. That's M prime, and this is now E prime. Okay, so we've got examples of each one of those. Now, for these last couple of questions, we are being asked, what is it a reflection over? Now, this happens to be a reflection over this y equals x line, meaning every point on this line has the same x and y, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And it's equal distance. D is equal distance to that line, and so is B is equal distance to that line. That's why it's a reflection over y equals x. Now this one down here is also y equals x, and then you would just reflect it. So I would count diagonally, or you could use a mirror for this question. So 1 diagonally, D prime would also be 1 diagonally. T is 1, 2, 3 and a half. There's your half. 1, 2, 3 is right there. F is 1, 2, 3, 4, 5 and a half. There's your half. 1, 2, 3, 4, 5 is right there. And A is 1, 2, 3, 1, 2, 3. Connect them up, and we should have the exact same figure. Flip to the other side. So when you have a diagonal line, you're just going to simply count diagonally instead of counting horizontally and vertically. So that's really the only difference. All right, so that pretty much brings us to the end of reflections. Thanks again for watching. Please give it a like if I helped you learn how to reflect an item, and I'll see you in the next video.